Hello there, and thanks for coming for this presentation. My name is Vinícius Gottschall Criscuolo. I'm a student at Pontifícia Universidade Católica de Campinas. And today I will tell you about my work that is a system dynamics based model to evaluate best municipal solid waste management practice for medium cities, the case of Itatiba, Brazil. So at first, to introduce the theme, I have to talk about the federal law that exists in Brazil. It's the 20,305 of 2010 that tells about the waste management system and in prioritized order to do a good management of the waste that is generated by the consumer of the products. Another thing that this law brings is the municipal plan for integrated solid waste management. And this plan is obligation of some cities to the cities if they want to have access of some resources from the union. And in the Itatiba, this plan was early produced. It was in end of 2019. And it brings a lot of perspectives for the management of the waste that is generated in the city. Another thing to introduce the team is about what it is this work. So we talk about this guy, the J. Forrester, that has an experience in feedback control system during World War II. And his premature access to the first computers provided an advance in their understanding of industrial process. So for J. Forrester, he was like he had a vision about a lot of whole system, mainly the industrial systems, and it made him make this kind of feedback control systems. So he applied a model of simulation. He evaluated that model, and he structured it for the different scenarios. So this work is based on the evaluation by a modeling by this team that we call system dynamics. So justification for this work is that the municipal integrated solid waste management plan was recently prepared at the end of 2019. And this work aims to evaluate future scenarios for the management of the municipal solid wastes through the elaboration of a simulation model based on system dynamics and propose the execution of different actions to public managers. So what we expect to contribute with this work, it's to diagram the management of the municipal solid waste from Itatiba, to develop an easy-to-use computational model and make it available to public managers to help them about the decision-making process, and to provide the municipal public agency with a technical subsidy to aid in the decision-making regarding the management of municipal solid waste. So they can do others public policies with more ease and with more certain of what they're gonna do, if that is gonna be good for the city, if that will contribute with the environment, the economy. So this is the end of this work. So the methodology for this work was adaptation from law in Kyoto that is based on exploratory studies and reference manuals, scientific articles, interviews with solid waste managers. This is to construct the basic model. And then you go to development of the solution through the elaboration from our models, like to represent the problem in the system. You have to try to represent the problem in reality by creating that system. Then you go to the computational application, use the Vinci simulator. That was one of the softwares used in this work. And then you validate the solution through few tests using three proposed scenarios. This case were three scenarios. So these figures in the bottom, it show a little bit of what is the components of the modeling based system. So it contains like this cloud that is like flow or collector limits, the flow system that shows where in the system where the units go. So if they will go to stock, so they will could improve or decrease the amount of things you're going to stock or decrease, and the flow through that represents the other combination of the system. So in this work we have 4 scenarios. So the first one was the base scenario. It was like if we get the system of Itatiba, the municipal management system from Itatiba, and we take that and don't do nothing, just to create the system and see how it responds. The scenario 2 was a temporary evolution for this destination of the organic fresh and municipal solid waste. These evolutions that we proposed was presented in the municipal solid waste plan. Okay. The scenario 3, that is a temporary evolution for the destination of recyclable waste, and the scenario 4, that is the scenario with all the increments, like the destination of organic fraction and the destination of recyclable waste. So in this image, we can see this is the system that was built. So the main thing of the system is to see how it is sensible. Like in this equation of the bottom of the landfill, we can see that each one equation of the system is gonna change the final results. That is the sensibility of the system, and it was created like this to try to represent the real scenario and the proposed scenario of the municipal plan of Itatiba, and to see if that is like can represent the reality of the city. Another thing to see is like this is the causal flow. So how those equations respond in the system. So you can see like if we want to know what kinds of variables will alter the landfilling rate, we can see that the recycling percentage, recycling rate, population, like all of this of those can alter the final results. It's the same for the cycle rate, the image down below. There we can see that this is the sensibility, how like population, how the collected municipal solid waste will affect the system. Another thing to see in this work is the validation. So validation is necessary to see if the model is like is nearly the reality or so you can propose you can see that if it's nearly reality, you can see it will your model is okay and it responds like in a good form. And if you know, you have to correct your model. And this validation was made by adaptation of a scenario that was taken from 2016. And this scenario, we have to this was the adaptation of this model. We just removed some of variables just to see, but in the model, the base model, it will maintain that. But in this, we remove just to see how it will respond of how the equations, how the system was built. It was adapted from the base scenario, and in the exclusion of the variables was made just to show those alterations. Okay. So the results from validation of the model was like in the landfill system, we can see in a year about 31,218 tons of waste will be sent to the landfill. So from 2016 to 2017. it's nearly the other data that we took from the SNIS. SNIS is a system that has those data, and it was this data was at the time was inputted there by the municipality. And in the image below, like the recycled wastes, we can see that there is a 930 tons of waste that we're going to the recycle. And in this NIS at the left, we can see that it's something like nearly 1,248 tons. So we can see at the first image and the second that the validation shows that there is approximately some response, some good response from the system, and there is some proximity from the system to the data that was inserted in the SNIS system. Another result is this graphic that we can see the recycled wastes. Now we talk about the basic model. We have all the scenarios: scenario 1, scenario 2, 3, and 4. And the scenario 1 and 2, like it's in the below of those lines, the blue and the red line, they are the same because we don't have any alteration from the system. And the scenario 3 and 4, we can see how it responds if we change the amount of recycled waste will be collected by the municipality. And this is expected to happen, like this is expected to happen, and those amount was expected to happen in the iteration of the scenarios. And this corroborates to the necessity to expand the system, because in the municipal plan, the system, if gonna receive that amount of wastes, it will have to expand his structures. And for landfill, we see that this is the final graphic about the landfill, and we can see the difference between the scenarios. Like from scenario 1, the base scenario, we can see that it will maintain that response. Scenario 3, it's like we input the difference between the recyclable waste, like 30% of the grade of the collection, 40 then 15%. And scenario 2, we have this base scenario for recycling and optimization of the organic fraction of municipal solid waste. And scenario 4, we have the organic fraction and the recyclable waste scenarios inserted that show how it will respond long term. This graphic was created using this 636,230 tons of waste that was estimative that municipality of Itatiba has, to see how in 20 years how it responds. So we can see just how it responds in the different scenarios. If the municipality uses those scenarios presented in the municipal solid waste plan, how they will react. And in this case, we can see the best scenario is the scenario 4. And the main thing we can see in this graphic, it's the great representation of the organic fraction in the system. Mainly because Itatiba doesn't have a system that treats this kind of waste. So the conclusion from this work, we can see that there is an importance of adopting public policies which are due to complying with the priority order provided by the, in Brazil, we call Política Nacional de Resíduos Sólidos, that's that federal law to 12,305 of 2010, within phases on the recycling of the organic fraction of municipal solid waste. And the recycling of recyclable solid waste that must be carried out with the expansion of the recycling system, as it will saturate if the action provided for or by the PMGs or the municipal solid plan occur. Another thing of this work, it's the innovation of these works, like is linked to use of computational modeling with the scenarios foreseen for a medium-sized municipality, Itatiba, in order to help municipal public management and optimize the urban solid waste management systems, directing the decision-making process. Those was the bibliographic reference used in this presentation. And that's my mail. If there's questions that I could answer. So thank you for participating in this presentation.